What do we call the right side? Non-metals. Good job. In the first column, alkali metals. Look at sodium. What's the atomic number? 11. Good job. Who's gonna tell me the atomic number for chlorine? 17. Very good. So now you need to pay attention to this because I'm gonna show you two concepts. We're gonna be talking about them over and over again. And if you're not paying attention to them today, you're gonna struggle. Okay, here we go. All of you take sodium. All of you take sodium. Na. And from the left side, first column. And we're gonna take another one, chlorine, from the halogen family, from the right side. Chlorine, here, Cl. Now, my friends, tell me the atomic number for sodium. 11. Guess what? Here is sodium. I'm gonna draw the atom of sodium for you. Here, sodium. Na, here is the atom. And first shell is gonna have 2 electrons. You told them 11, am I right? So what do you think, how many ones left? 2 out of 11, 9. So the second shell is gonna have 8 electrons. And we have 1 electron left. Here. It's gonna be in the outermost shell, 1 electron. Only 1 electron over here. Do you see? So I have 2 electrons in the first shell, 8, 2, 8, and 10, and 1 is what? 3, count, 1 and 8, 9, and 2, 11. So the first group in the outermost shell has 1 electron in the outermost shell. And they love to get rid of it. Do you know why they love to get rid of it? Once they get rid of it, they're gonna have only 8 electrons in the outermost shell. They're gonna be happy and stable. Like the neon, the noble gases. All the way to the right, look at the periodic table. That sodium wants to be like the neon. Has 8 only electrons in the outermost shell. Atomic number for chlorine? 17. You get an extra credit for that. All right, here we go. So let's draw the chlorine. Here is the chlorine. Cl has 17. So the first orbit is gonna have 2. Second orbit is gonna have 8. 2 and 8, 10. So how many left? 7. Here is 7. 7. So it needs how many to become 8? 1 electron. And if it gets that electron, become like argon. Look at argon, the noble gases. It becomes like argon, happy like argon, and stabilized like argon. So it needs 1 electron. So this one needs 1 electron to be happy like argon, here. To be like argon, like here. And this one needs to get rid of this to become like neon. You see? This is the ultimate goal for each one of them. So this one wants to be happy, wants to get 1 electron. And this one is desperate when I get rid of the electron. Look how these elements react. Watch. This one is gonna get rid of the electron here in the A plus. And it become what's called an ion, positive ion. Here, positive ion. You see? Guess what? This positive ion, pay attention to this. It has positive charge because it lost 1 electron. All right? Look at this one. Watch this. This one needs an electron. So once it gets the electron, usually it gets from the left side of the periodic table. So it becomes a negative ion here. Negative ion. I'm gonna give you a hint to memorize it for life. Do you love cats? I love cats, but I don't have a cat. Because I love pets from a distance. You got the idea. They need lots of work. Okay. So if you love cat, think of your positive cat. Guess what? We call this in chemistry cation. Do you see? I give you a hint to memorize it for life. Cation, my positive cat. So cations carry what charge? Positive ion, cations. And I give you a hint about the cat. Like, what did I tell you about protons? Start with which letter? Positive, proton and positive. How about neutrons? What did I tell you? Nothing, nada, neutron, nada, nothing. So, I give you hints like this to memorize it for life. I make up these devices myself. I used to use them in college. If you want to make your own device, that's fine with me. Now, my friend, I want to look at the other one. You're going to hear this a lot. Cation, cation, cation. Now you know my positive cat, my positive ion. Now, all of you look at the chlorine. The chlorine gained 1 electrons. It became a negative ion. I'm going to give you a hint. Do you go for an interview eating onions? Of course, you're going to go there, hello. They said, they're not going to hire you. Am I right? So we say, Mister, we say basically negative. Onions, negative, but they're healthy for you. So remember this. Guess what? What do we call the negative ion? Why am mentioning onions here? Anion. What do we call it? Anion. Did I give you a hint for it? What is it? What is it? The onion and the interview. So do not forget, cations carry what charge? And what hint I give you? What device, what mnemonic device I give you to memorize it? Cat, positive cat, my positive cat. How about anions? What hint I give you? Mister? What hint I give you? Lagoon and the other guy. What hint I give you here? Onions. Going for an interview. Negative onion, negative onions. This one is gonna react with this because opposite attract. Opposite attract. Here, Na with the Cl, they're gonna form you this compound. NaCl. And this one you eat and eat every day. What is it? What do you call that? Sodium chloride. What do you call it? You and I eat it every day. It's in your pizza, in your food every day. Sodium chloride. What do you call it? Salt. Table salt. Salt. All right? So you got the idea. So with that being said over here, so here is the sodium. This side like to lose electrons and become cations. And this side gains the electrons and become anions. Opposite attract and they form new compounds. Okay, here it is. Structure, chapter 3. And here is what we were talking about, my friends. Do you see? Ion. It's basically an atom or a group of atoms losing an electron or gaining electrons. If they lose electrons, electrons are negative charge. They become cation, positive ion. If they gain electrons, what do you call them? Negative ion. And I give you a hint. Onions. That's anion. They form opposite attract. Cations and anions are attracted together. So they're gonna form what compound? Ionic compounds. It's the reaction between metal, the left side, cations, and the anions and the non-metals from the right side of the periodic table. And they form ionic compounds like sodium chloride, like salt. Did you get it?